All right, folks, this is short and sweet. If we're looking at hand-coded scanners as an alternative to our sort of auto-generated table-driven scanners or our auto-generated direct-coded scanners, the idea is we're relying on our developers' abilities to recognize opportunities for optimization. So rather than relying on, again, the auto-generated form of things, we're saying maybe our developers can use a hybrid of sort of tables and direct coded, and they can recognize places where they can improve on one or the other or use the best of each. So there's all sorts of things that your developers might wind up doing. They might wind up throwing in extra features as well, extra functionality as well, standardizing the input format, stripping out comments, throwing in extra fixes like saying, okay, well, what I'll do is instead of having this big DFA that has a separate series of states for every one of the different keywords, and then another one for identifiers and somehow separating all those out, then instead what I'll do is have one that just lumps the keywords in with the identifiers, and then at the end, if it says that it's an identifier, I'll have a separate dictionary lookup that says, is it really one of these keywords? Right? So you can start throwing in fixes to try and really cut down the size of the table and make that side of it, the DFA side of it, more efficient, and throw in either a pre-processing or post-processing step that improves the performance and gives you the same functionality in the long run. Again, in terms of things like rollback, right? If we're actually doing this by directly reading the character from the input stream and then putting it back into the input stream, those are expensive operations, right? Those are slow. File I/O is just by nature slow. So it makes more sense if we go through and say, well, instead of actually working from the file, we'll read chunks of the source code into an array, for instance, into some kind of buffer first, and then we'll work from the buffer so that if we're reading things and putting them back, we're just basically changing which position we're looking at in the array rather than actually pulling things from the input stream and then putting them back and then reading them again. So for something like that, we might be going through and saying, okay, well, let's read the next 500 characters or 1,000 characters or whatever it is into our buffer, and then we'll just work on that. And then when we hit the end of the buffer, we'll read the next chunk in. There are some issues that you run into there with rollback. As long as you're rolling back within the buffer that you're currently in, that you currently have loaded, everything's fine and efficient. But what if you roll back past the start of the buffer? Then what do we need to do? So we would either need to go through and kind of bring back that buffer, or maybe remember the last buffer or the last couple of buffers, so that if we need to roll back. So we're trying to come up with this sort of sweet spot of how much to buffer and how often am I going to roll backwards past the start of my buffer, and what should I do there. And again, this is the kind of thing that you can play with and tweak as a developer when you're doing this in a sort of hand-coded format. So there are lots of situations where your developers can pick the best of both worlds and then throw extra optimizations in on top, throw extra customizations in on top. And so this is still extremely widely used, right? A lot of compilers are driven off of this approach where we're going to rely on our developers to come up with an ideal approach. More for cases where you're expecting your compiler to be really widely used over a long period of time. If you've got a language that's more specialty driven, where you've got something that is going to be used by a very small group of people or over a short time period or for a very specialized purpose, maybe then you're not going to put in all the effort of handcrafting one of these things, and you're going to say, okay, well, it makes way more sense for us just to go through and use one of our tools to auto-generate something for this little language for our small group. So it is this trade-off, but if you've got something where long-term it's worth it to you to get everything you possibly can out of it, then you might go through and handcraft your solution. All right, that is where we will leave the scanning side of things for now. In our next couple of weeks, we'll start looking at the parsing side, where we're saying, okay, if I've got my stream of tokens, what does that represent in terms of the syntax of the language? Does it represent a while loop? Does it represent a variable declaration? Does it represent a function declaration? Does it represent an entire valid program? What does it actually represent? So that's where we'll go next.